Okay, so next we're going to look at a command that allows us to create links between files. And this is often used to basically take a file that exists one place on the disk and make it appear to the system that it appears more than one place for one reason or another. There are two kinds of links. There are symbolic links and hard links. So we'll look at both of them. If I take a look at what's in this directory right now, in my home directory, this is /home/Perry. I have these four files, Perry1, Perry2, Perry34, and Perry99 that we created earlier. I'm going to go ahead and use a text editor. You don't have to do this, but I'm going to do this just so that I can show you some interesting properties about this. We'll deal with text editors a little bit later in the course, but for now I'm just going to use a text editor to edit this Perry1 file, because remember, we just created these using the touch command. They didn't have anything in them, so they're empty, but I'm just going to add some text there. How about, hello there. Okay, so we'll do that, and I'm going to save that, and if I create a detailed listing now, you'll see that file now, as I'm showing here, has a size of 13 bytes. This is the size that you see right here. So the others have a size of 0. There's no content in them. This one has a size of 13 because of the characters that I typed in there. So now the file has a size, and that'll help with some of the comparisons that we're going to do between these two kinds of links. So the first kind of link we're going to produce is a symbolic link, and that's really pretty easy to do. We use the command ln with the -s. S means symbolic, so we're going to create a symbolic link to the file Perry1, and we can call it, how about sim Perry1 if you like. We'll call it whatever we want to. Of course, these are in the same directory, but that's just for simplicity, for demonstration. We could put the symbolic link anywhere we want. You know how to specify a path of where to put that in the file system. So if I take a look now at what we have, you'll see that now I have this new symbolic link here called sim_Perry1, which references Perry1. You'll also notice, take a look at the size here. It has a size of 6. Okay, it's not the same as the size of that. Why? Because all this symbolic link is another file, and the only information that it has to contain is the information about which file it is referring to. So I can do something else, ls-l, but I'll also add the option I to the end of this. I means I want to see the inode, which is kind of an internal Linux reference to which file we're talking about. Okay, so each one gets its own inode reference, so the I is for inode. And we can take a look. Here on the left are the inodes for each of these files. You'll see that Perry1 has an inode of 671625 right here. Okay. And the symbolic link to Perry1 has a different one, 671774. So those are two different inodes. Those are actually two different files, but this one refers to that one. And in practice then, I could use this name as if it were that file, any place that I wanted to. And so this is rather handy again, because it means that we can use the content that's in a file, but in other places than where that file actually exists. And this will be handy for a lot of the things that we'll do later, and some scripting and that sort of stuff. So symbolic links. Symbolic links are very handy. There's a second kind of link, which is called a hard link. To make a hard link, you have to be on the same the thing has to be stored on the same medium as where you're trying to create the hard link. But like a symbolic link, it's going to give us another name that refers to the same content, but at kind of a deeper level. That is to say, there's only going to be one file when we're done, but it's going to have two names that could reside in two completely different places. So I know this is a little abstract. The differences between the two are not terribly clear at this point, but this will become clear with time and use. So let's go ahead and make a hard link, and so we'll make a hard link to the same file, Perry1, and we can call this like so. And now we've got a hard link, so let's do the same command that we did before to look at the long version and see both of them. Now notice there's our symbolic link. Remember, that has a different inode, okay, than the original file, 671625. But notice the new hard link has the same inode. Okay, so what does this mean? It means that these two names refer to exactly the same file. And again, these could reside in different directories. I just have them in one directory for the sake of convenience in explaining. Notice also that these two are showing exactly the same size. You see that. So how is this different from a copy command? Well, again, if I were to copy, let's just do that, cp Perry1 to Perry1 new, for instance. Okay. And again, if I do that, notice that this one has a different inode. Perry1 new has a different inode than the original Perry1. Okay. So these refer to two totally different files. So I could delete one of those two, and the other one would still remain. Furthermore, I could change Perry1 new if I wanted to. So there's our text, right? All right. And now then, if we take a look, you'll see that that one is longer than the other one. But these two they have a totally independent life now because the one has been changed, the other one wasn't. But now if I were to edit, say, the Perry1 file, and let's just shorten it a little bit. Remember, it was 13 bytes before, right? And now we take a look. You'll see that now it's only 7 bytes, but then so is the hard link. So these two don't have an independent life. They're just two different names for the exact same file. Remember, they have the same inode. That means they're the same content. Whereas when I just copied one, it has a different inode. It's different content. And then finally, with a symbolic link, I come up with a link, but it's basically just referring to where that thing is and where it exists. So you'll notice something interesting then with the symbolic links. It's easy to break a symbolic link as well, that is to make it non-functional, if the thing that it refers to isn't referred to by that name anymore. So if I were to, for example, move Perry1 to Perry1, I'll just call it Perry1A. How about? Okay. So we move it there, and let's take a look at everything. Now, notice this is red. Why? Because I broke the symbolic link right here. And it just occurred to me that I borrowed a little bit from the next part of the lecture because, in fact, I used a command that we haven't seen before, which is the move command. We've seen the copy command, but this is the way that we actually change the name of something. We use the move command. Now, move is pretty handy because it can be used both to rename things and, in fact, to move them to other locations. So right now, then, I'll go ahead and delete this symbolic link that's broken in any case, right? Sim underscore Perry1. So let's rm to remove sim underscore Perry1. Okay. And then let's also move Perry1A. We can just rename, so we could say Perry1A to Perry. And then as we look at that, then you see that it's just called Perry now. Okay. But we could also move that file to a different directory. So remember, we had our documents directory. So let me just go there. And let's see what we have here. Looks like we've got all of these files. Let me just get rid of them all. So I'll just rm star from there. And you'll see that as I show what's there, there's nothing there, right? So let's go back and, whoops, ls-l. And you see here we have this file Perry. Let's say that we need to move Perry into the documents directory. We would just use the move command. We would say Perry, and where do you want Perry to go? Well, I'd like it to go into documents/Perry. We could call it Perry1B if you want to, right? So let's move that. Whoops. mistyped, move documents slash 1B. That's better. Do note that all of these directory names and file names are case sensitive. So now if I go to the documents directory, then there you see Perry 1B. The file has been moved there. Okay, so far we've just been playing with the directories that have been provided for us already, but we can of course create our new directories, remove directories, move things from one directory to another, obviously, move directories around, whatever we want, and we can do all of that from the command line. So let's have a look at the basic commands for that. The first one, we're here in our home/Perry/documents directory right now, and I will then go ahead and create a directory using the makedir, mkdir, make directory command. So why don't we call this makedir Monday, since it's Monday right now, and you'll see that in fact there's a directory now called Monday, so I can cd to Monday, and of course there's nothing in there right now, but if we wanted there to be, there would be. So let me go back out and show you the opposite, which is rmdir Monday, which removes the directory, and now if I get a listing, you'll see that it is no longer, that directory no longer exists right there. So let's go back and let's create the directory again, and let's change directory to Monday, and take a look. There's nothing in there, but let's create some file. So we'll touch, how about some file? Isn't that what I called it? Okay, so there it is. So there's some file in the directory. If I go back and I use rmdir now to try to remove Monday, it says fail to remove it because the directory is not empty. So if you want to remove a directory, the directory has to be empty. So we have a couple of choices. We could go into Monday, go ahead and use the rm command to remove the file called SomeFile, and then we could step back out and remove the directory. That's a reasonable way of doing that. But there is another way to do it. We can actually do it using the rm command. So let's see what we can do there. If we were to say rm Monday, it says you can't remove it because it's a directory. Okay, rm is for files, rmdir is for directories. But we could do this, rm-r Monday, and let's see what that did. Now Monday is gone. What does that do? R means recursive, and so what rm-r does is it will go into the Monday directory and further keep drilling down into any directories that exist in there, remove all of the files that are within that directory, and then step back out and continue that process until all that's left is the empty Monday directory, and then remove the Monday directory. So you can remove a very substantial hierarchy of content that way very, very quickly. Now, observe, you can also get yourself in a whole lot of trouble very, very quickly this way, right? Let's go to root, and rm, don't do this, -r, then I would probably wreak a lot of havoc on my system, right? So you don't want to do that. So be very, very careful when you do that. You want to double check that you're not destroying anything besides the content you're intending to destroy when you do that. Okay, so next, let's take a look at the ways that that we might show some of the content in files. I kind of gave you a little look ahead and showed you one of the editors called the Nano Editor that's available on most modern Linux systems these days, but we're going to work with editors a little bit later to edit text and such interactively. But what we want to do right now is see what we have available from the command line that basically just executes a command to show us content. So let me go back into this directory, and let's see, did we have any, we have a couple of things that actually have some content. So we have that hard link we created before. We also have this file right here, the Perry1_new, that has some content there. So the first command is this one. It's called cat, which I think is short for catenate. It basically means read the contents of this file and put it to the standard output. Just catenate it there one character at a time to the standard output. But what we do is type that and then the file name. So I could say Perry1_new, for instance, and then you get the content that was in that file. Or we could do this and say, and there's that one. Okay, so we can see the content that's actually in the files if it's text content. You want to make sure that it's content that can actually be read. If it were, for example, a program or an executable file, or a graphics image or something like that, then there wouldn't be anything useful that we could necessarily see there using just the cat command. Maybe using some other commands, but not the cat command. But that is the first one. We can also look at things that are in directories. Remember that in our documents directory we had some things, right? What do we have there? Perry1b. Let's see, is there any content there? Yeah, it's got a little bit. So obviously we could catenate that from here, but let me just go back to where I was so that we get used to qualifying things with a full path. So we could type cat, and what was that called? Perry1b, right? And then you get the content from Perry1b, which is in that other directory. So that is the cat command. As I mentioned, it can be very important to make sure that is it actually something that you can view. And one thing that's very handy for that is this command called file. File should tell you the type of file that the file that you're looking at is. So I look at that type of file, it says that it's ASCII text. That means it's something that I should be able to view as text. So that's a good way to have the operating system try to determine for you, or the utilities of the operating system try to determine for you what kind of content you're actually looking at before you try to look at it as if it were text. So next, we might want a little bit bigger file so that we can see the advantage of using different tools. So let's see, we need some text, right? So let's do a little search here and generate some lorem ipsum text. You know what that is, right? If you don't, you're about to find out. Let's see. What do we want? How about 1,500 words of lorem ipsum? There it is. It's just a bunch of Latin, right? How's that? So let's go ahead and grab this text. Let me just scroll down here. Yada yada. 17 paragraphs, 1,500 words, 10,000 bytes. I'm going to copy that right there. And I'm going to go into an NO editor and I'm going to call it lorem. And I'm going to paste all of this in here. You notice paste, if you're used to Control V on Windows, I know I am. I often accidentally hit it. It's Shift Control V most of the time in Linux and Shift Control C for copy. So it's a little bit different. But now then, you see, of course, it didn't put any new line characters in there. Okay, so all the paragraphs are just on a single line, but there's your 17 paragraphs. That's fine, though. Let me just write that out to that file, and we'll exit. Okay, so now if I cat lorem, you'll see there's all of our content. It just goes one paragraph after another, one word after another, straight to the output. Well, I can scroll up, obviously. I'm using my scroll wheel to do that, or you can use the scroll bar over here to scroll up and look at the text. But, what if you wanted to look at it kind of a page at a time? One way to do that is using the more command. So we'll say more with lorem. And now we're seeing a page at a time. And what I can do then is hit the space bar and I'll see the next page of text. And the space bar, I see the next page. I think enter works as well. Well, enter goes down one line. That's what it is. Okay, enter is one line. Okay, and Z will go down a page, but you can't really go back up that I know of with the more command. Indeed, we ought to check out the manual. Indeed, we ought to check out the manual page for more and see what's available. Let's see. Various things here. Don't scroll, blah, blah, blah. Okay, so let's continue down here. Let's see. What are the interactive commands? Here we go. Okay, so space displays the next k lines of text, defaults to current screen size. Z is same thing, page down. Return is basically page down. D is page down. Q is interrupt or exit. S is skip forward. Lines are screen full, so S and F. You can, kind of figure out what you want to do. Let's see, how do we go up? Yeah, it seems like we just go down with the more command, right? That's kind of what I'm thinking. So most of the time, people will use less instead of more because less is more, right? Less sounds like it must be less sophisticated than more, but it's the other way around. It's another pager utility for the command line that allows us to do more. You can scroll forward, you can scroll backward, as you see, by lines, by pages. I told you you've got W and Z that can be used to page forward, and you can read this and find all kinds of other things. By the way, page up and page down also work in addition to W and Z. So why not say those? Well, you may not have a handy page up or page down on some keyboards, or they might be function keys or whatever. It might be less convenient on a laptop, but it just depends upon the nature of the device that you have. But anyway, I'm going to hit Q to quit from that, and let's say less lorem. This is a quick way to look through content. You think, why in the world would I ever want to use something like this? And the answer is because it's really fast. You type quickly at the command line, and you can just get in here, scroll up. I'm scrolling back up, I'm scrolling back down, I'm scrolling back up, I'm going line at a time, and when I'm done, I hit Q, and I'm done looking at that content. So it's a really fast way to get around in files, much faster than starting up some kind of editor and then scrolling down one line at a time or something like that, or using scroll bars. The mouse is very convenient, but it's not always faster, not when you get used to this. The last two commands that we'll look at are the head and tail commands. These are really very handy. We'll type tail of lorem there, and what it does is actually, notice this is not the whole file. Remember there were 17 paragraphs? I've got about 5 paragraphs here. But what tail does is it gives me the end of the file. We had integer id diem quis terpus, etc., etc. So it's the last 5. It's not the beginning of the file, but you notice that's the end of the file, hence the word tail. I can also type head lorem, and I get the beginning of the file, okay, the first few lines, okay, so just giving me the first little bit, and notice that starts with lorem ipsum, okay, so that's the beginning of the file. So what good are head and tail? One very common application of these, there's a way to set these up so that they're constantly updating as a file is being written to. And this happens very often, for instance, with log files. So you'll have a log file where there's some log information being generated for any number of purposes. Could be security-related things, or log files for a system that's booting up or whatever. As that file is constantly being updated, what you really want to know is what just got stuck on the end of this thing. And so you can set this up so that you're constantly getting an updated output showing you what new things are being added to a very large file. You don't want to have to scroll through that thing constantly, but rather you'd like to have maybe one terminal up over here where you're seeing all of this stuff as it updates, and maybe you have another terminal over here where you're operating, doing some other things, or typing and doing things, but over here you're watching what's happening with the logs. So very common application, and you can do that using head and tail, and we'll look at mechanisms for doing that, for peeking at files and for keeping that updated continuously as we go through the course. So that's it for this lecture and the content for this week. That really gets us through Chapter 3, the Basic Bash shell commands. And let's just briefly review the commands that we went through, so I can bring them back to your remembrance. If you don't remember all of the ones that I talk about now, you want to go back and review those. So we talked about ls with various options to be able to show what the files are in a directory. We talked about navigating using cd. We looked at both the period and the double period that refer to the current directory and also the parent directory. We talked about the pwd command for printing the working directory. We also talked about the touch command for creating a file or updating its last modified date. So that one was very, very important. Let's see, we talked about the ln command. Whoops, let me put a little space in there. I'm just typing them out to bring them back to your remembrance. We looked at the ln command for creating links. We looked at the mv command for moving or renaming files. We also looked at the rm command for removing files. We looked at the makedir commands and the rmdir commands, and also looked at a special case of rm to remove both a directory and its contents when it is non-empty, which we said was a little dangerous. We looked at cat and more and less just now, so that we've got those available to us. Also tail and head for looking at just the first or last few lines in a file. Let's see, what else did we have? I think that's about it for this time. So what I strongly encourage you to do, of course, I'm giving you homework, but the homework may not obviously cover every single one of these commands in great detail, but you should practice with these. These are kind of like the basics. It's kind of like arithmetic. If you have to learn how to add and subtract before you can do anything else really in arithmetic, and you expect that addition and subtraction become kind of second nature for you. So you want to play with these enough that they become a little bit second nature. Navigate around your system, see what kinds of files are there. I urge you not to willy-nilly start deleting things or moving things around when you don't know what the things are. So you want to be careful about that. But go ahead and create your own directories, your own files, and then make use of these commands to navigate around until you start to become fairly familiar with it, in addition to doing the homework. And I think you'll be in a pretty good position for the upcoming weeks. So next week we're going to look into more of the shell commands that we can enter into this shell, and in particular start looking at handling data and managing things on the system using the command line. So it'll be more commands, but some that are very functional, that do a variety of things. And where are we going ultimately? Well, ultimately in this course, in addition to doing this on Linux, of course, we'll be doing some things in Windows also, but on both platforms, you're going to learn how to write some basic script code to take some of these commands and put them together with some logic that's testing things to do a variety of interesting tasks. And this will serve you well. It'll be basically a toolkit that will allow you to really exercise an enormous amount of power from the command line to administer systems, to pen test systems for those of you who are in cybersecurity, et cetera, to automate a lot of tedious tasks for everyone, whether cybersecurity, computer science, whatever. You can automate a great deal from the command line that you just simply can't do with the graphical user interface. So you need these tools, and this is the start. We have to walk before we run. So let's walk through this content then in the coming days. If you have questions, be sure and post to the class forum, and we'll try to get you some help there. That's the best place for questions about the homework or about anything else. Any other observations that you have, that's fine. Go ahead and post them up there, and talk to you soon.